Okay, I wanted to start off today by just talking about a couple of questions that'll sort of review some of the things we did on dot product and cross product, and then we'll introduce a couple of other little concepts as we're going along through here. So here's the first sort of question. We've got a vector u, a vector v, and a vector w here, and we want to find this thing here, u dot v cross w. Now this has a specific name. This is called the triple scalar product. And it's called the triple product because obviously you've got three vectors here that you're multiplying together. It's called the scalar part comes about because the answer that you get, and that's not how you spell answer, so we'll fix that. The answer that you get at the end of this is a scalar. And the reason is kind of the order that you have to do these things in. It's often just written out like this, u dot v cross w, but there's sort of implied that there are brackets here, that you have to do this cross product of v and w first. And the reason is, if you do the cross product of v and w, you get a vector. You can then do the dot product of that resulting vector and vector u, and that'll give us a scalar at the end. If you try to do the dot product first, u dot v, because the dot product gives you a scalar, you would then have to try to do the cross product of a scalar and a vector, which is impossible because you have to have two vectors in order to do the cross product. So this is the triple scalar product because it gives us a scalar. There is also what is called the triple vector product, which would look like u cross v cross w. And of course it's called the triple vector product because the answer here is a vector. Doing the cross product of two vectors gives you another vector, and then the cross product of that vector with your first vector is another vector. Okay. So we've got these two triple products. So let's go ahead and work out what the triple scalar product is of u dot v cross w. So the first thing we're going to have to do is, let's just write out what our vector u is. U is going to be 2, -1, 5. We're going to want to take the dot product of that with some other vector. And this vector is going to be the result of doing the cross product of v and w. So how do we do that cross product of v and w? Well, we make our little chart here, I, j, k. We put our components underneath each one of them. So we're doing v cross w, so we need -3, 2, and 2, and 1, 4, and -6. Give ourselves another copy of I here, which is -3 and 1. And then we do the cross product here. So let's see. Our I component is going to be 2 times -6, which is -12, minus 2 times 4, so -8 gives us -20. Our j component is going to be 2 times 1 minus -6 times -3, so that's 2 minus 18, so -16. And then our k component, we imagine the k coming out to the front here. We do -3 times 4, which is -12, and then we subtract 2 to get -14. And then we do the dot product of these two things. So we multiply our corresponding components here and then total them all up. So 2 times -20 gives us -40, plus -1 times -16 gives us 16, and then 5 times -14 gives us -70. So -40 plus 16 minus 70 gives us -94. And that would be the triple scalar product of those three vectors. And as we expected, our answer here is simply a scalar.